Okay, boleh start.
Assalamualaikum. We are from Group 4. Today we are going to presenting on machine learning and medicine. First, let me introduce all our group members. Next slide. This is our proof of discussion. Next. Okay, these are our group member. First is SOFEA. Next is SITI HASRAN. After that is AIMI LIYANA. Fourth is HUSNA. And lastly is me, FIKRI SHAZLAN. Okay, next. Okay, this is our overall we are going to present today. First is the introduction. Next is the method. Third is the discussion. Next. Okay, first is the introduction. Next. Okay, what is machine learning? The definition of machine learning is a product of improved computational power, storage memory, and generation of staggering volume of data by using computers. The role of machine learning is to implement in natural language processing to interpret unstructured text data. It also allows describing the relationship between variables by using algorithm set of mathematical procedure. And lastly is the development of learning healthcare system. Okay, next I will pass the presentation to AIMI.
Okay, thank you, Fikri Shazlan. So, supervised learning. Supervised learning is techniques that involve a model that have been trained with certain features to exhibit a known outcome. Prediction of outcomes, which are either discrete or continuous, can be made when applied to new data once the algorithm is successfully trained. Okay, for discrete is also known as classes or classification algorithms. For example, impossible or definite, positive or negative, benign or malignant. While for continuous is a prediction that involves continuous value. It also referred to as a regression algorithm. Regression is initially used in statistics, so therefore the use of this term varies in machine learning, which are binary outcomes and continuous outcome. For example, the score from 0 to 100. Okay, next. Okay, next is unsupervised learning. Unsupervised learning is a technique that does not involve any predefined outcome. This learning is only used to explore and find undefined patterns that occur in the testing dataset, as there is no input or features trained for the user by using algorithms. The dimension this supervised learning is also known as dimension reduction technique, which comprise of principal component analysis, latent duration analysis, and TSNE processes. This unsupervised learning is to reduce the computational cost as the number of features in analysis is low. Next, I will pass to my friend.
The next one will be the method. Next slide, please. So, the first one is the data set that we're using in this paper is breast cancer reconciliation diagnostic data set, which obtained from the University of California, Irvine, UCI, Machine Learning Repository. In order to create this data set, a total of 699 samples have been taken. 241 instances has been recognized as malignant, while the rest are benign. In this paper, 9 features has been classified, including the thickness, cell size, cell shape, adhesion, epithelial size, bare nuclei, then chromatin, normal nuclei, and mitosis. All these features were inferred on the instances using the value scale of 1 to 10. The scale of 1 indicated as benign, while the scale of 10 indicated as malignant. Next slide. In this paper, our statistical programming language has been used as a programming tool. So this programming language is supplementary to S language. It provided various outstanding packages for machine learning, which was pliable and practical to use, hence making R a commonly used tool among the active users. Its programming is also very systematic and accessible even for non-programming individuals. The next one will be conducting a machine learning analysis. So in this conducting analysis, there are 6 required steps, which are, next slide please. Importing and preparing the data sets, training the ML algorithm, testing ML algorithm, assessing sensitivity, specificity, and accuracy of the algorithm, plotting receiver operating characteristics, curves, and lastly, applying new data to the trained models. Next. So the first step is importing and preparing the data sets. As I mentioned previously, the data set is obtained from UCI repository by using a code. And then the first thing to do is the missing data will be removed and recovered. For example, the missing data of question will be replaced with an A, and the class variable of 2 and 4 will become 0 and 1 respectively. Then a table has been tabulated to represent in the data set in form of matrix. Since training ML algorithm is necessary, the dataset is separated into 2 segments. One contains 67% of the dataset for training purposes, and the remaining 33% dataset will be used for evaluation. Next. So this is an example of the table that have been tabulated in form of the matrix. Next. The second step is training of ML algorithm, which we will use logistic regression using generalized linear models with L1 least absolute selection and shrinkage operator regularization. The second one, support vector. The third one, artificial neural networks with a single hidden layer. In support vector machine, it is essential to separate the classes using hyperplane. Hyperplane can be defined as a linear decision boundary. So for artificial neural networks, it is an algorithm based on neural structure of mammalian cortex. The input neurons are arranged with the neural networks, which will be processed in the hidden layer before eventually passing to the output layer where the final outcome will be decided. And then the activation output, the activation function will transform the information using an equation of y equals the activation, sum of weight multiplied by input plus the bias. The next one, I will pass to my friend Sarah.
Okay, thank you, Sophia. So next step is testing the machine learning algorithm. So the algorithm which was trained with the true outcomes, which we have known, is necessary to compare their predictions for validity purposes and the performance of the trained algorithm itself. So as we can see, this is the code given which the predictions from the trained models was extracted on the new data. So next. Next. Okay. Next is assessing sensitivity, specificity, and accuracy of the algorithms. So the algorithm was evaluated using simple methodologies as mentioned. So the sensitivity means the ratio of true positives correctly defined by the test. Specificity is the ratio of true negatives correctly defined by the test, while accuracy is the ratio of the times the classifier is accurate. So, and the data from classifier are presented in confusion matrix form. As you can see, okay, Next is plotting reservoir operating character. Okay. This is to illustrate the relationship between the model sensitivity, which plotted on the y-axis, and specificity, which plotted on the x-axis. The ROC curve interpretation is facilitated by measuring the area under the each curve, or called A, classified by each algorithm by giving a single value. Lastly, the new data was applied to the trained models. The models are developed to not interfere with the relationship between variables, but instead produce reliable predictions from new data. And the use to train models to make predictions from data. Okay, next. Okay. Other additional techniques involve ensemble learning and also natural so as algorithms is grouped together to create a more robust, maximize the performance of the predictive model. And means the computers are taught to interpret links called term document matrix or TDM, which as into smaller tokens of text, such as individual words, content within. Okay. Next, I'll pass to my friend.
Okay, next is the results of the trained algorithm used. So in this paper, there are 3 trained algorithms used, which is the GLMs, SVMs, and ANNs. And all 3 trained algorithms are able to classify the nuclei of tumor biopsies, with the base result is obtained by the SVMs. So the accuracy, generally the accuracy of the 3 methods between average for about 0.95. The sensitivity is about from 0.97 to 0.99, and the specificity is between the 0.85 and till 0.94. As for SVMs, the results obtained is with the high accuracy that they have 0.96, and the area under the curve for the SVMs is 0.97. By using the voting ensemble, the prediction performance has elevated to some extent, which the results obtained are 0.97 for the accuracy, 0.99 for the sensitivity, and 0.95 for the specificity. So in the discussion part, all the trained algorithm used in this paper has a high accuracy, which all the algorithm are able to differentiate between the benign and malignant tumor despite the differences in the way all the 3 algorithm works. Second is the R environment, which is the freely accessible programming software that is used for the training. It is used for training the users, which is the medical practitioner, to train on this programming software by using their own dataset. So lastly, it is necessary to be able to distinguish for the differences between the algorithms trained in order to reduce the bias base risk in training the predictive algorithm for the medical practitioner. So to conclude, the simple techniques are used to train the medical practitioners on the theory and the practical of the machine learning in their fields by using their own data set. And further practice can be done to enhance their skills on artificial intelligence by using more complex data. So here are our references. That's all from us, Group 4. Thank you.